To condense a logarithmic expression into a single logarithm, it simply means to take an entire expression of logs and rewrite them as a single logarithm. So these two expressions are actually equivalent to each other. Similarly, we could do that for the other two using the log properties that we've actually seen today. Now, what we've already covered is taking a single log expression and rewriting it in an expanded form. But in this video, we're going to go over how to condense them, basically that operation in reverse. So we're going to be needing to use these three log properties that we already know: the product property, the quotient property, and the power property. And some tips for recognizing when you want to use which property in condensing is whenever you have a sum of two logarithms, it can be the product of the values within those logarithms. When you have subtraction, it's the quotient of those two values. And when you have the product or a coefficient in front of a logarithm, that can be brought into the logarithm as a power. Now, what I'd like you to do is see if you can justify the three solutions that I'm about to give you using these properties, and then I'll go over the solutions with you. So this expression number 2 is actually equivalent to this, and expression number 3 is actually equivalent to this. So take a moment and pause this video to see if you can justify, using these three properties, why those two values are actually equivalent.
Log! Boy, oh boy!
Yes, log. All kids love log.
What rolls downstairs, a motor in pairs, rolls over your neighbor's dog. What's great for a snack and fits on your back? It's log, log, log.
Okay, let's take a look at the solutions. For the first one, I'm going to make note that I have two coefficients to start off. So I'm probably going to be using the power property. Those coefficients in front of the logarithms will go into the logs as exponents. Notice that the 1/2 coefficient became a 1/2 power, and the 3 coefficient became a 3rd power. Now, one thing to keep in mind is that an exponent of 1/2 is the same as the square root of x. So I'm going to make note of that right here, that this log x to the 1/2 power is the same thing as log of the square root of x. So this is really log of the square root of x. Anytime I have a rational exponent, I can think of it as a root. Well, I'm going to point out that this is now, I have no coefficients left. So I have no more coefficients. I've brought them in as exponents, so those coefficients are out of the way. But I still have a sum of two separate logarithms. Well, a sum, I can use that product property and rewrite it as multiplication of what these two logarithms are of. So in this case, that'll be x to the 1/2, which we've already noted is the square root of x, and x plus 1 to the 3rd. So this will simply be the log of the product of those two values. The square root of x times x plus 1 to the 3rd. So it's x to the 1/2, which is square root of x, times x plus 1 to the 3rd. And that turns out to be a single logarithm in simplest form. So I'm going to box that as my final answer. Now notice I used square brackets here. The only reason I'm using square brackets is to show that this logarithm is of this entire value. And I'm using square brackets as opposed to parentheses because I already have a set of parentheses here, and the square brackets help me keep track of all of my terms. Okay. The second one, again, I had a coefficient of 2, so again I will be using the power property to rewrite that expression as natural log of x plus 2 to the 2nd power, because it had a coefficient of 2, and there was no coefficient here, so I'm just going to leave that as natural log of x. Then I notice I have two logarithms with no more coefficients, and I have a subtraction in between them, so I'm going to use the quotient property. And that subtraction will end up being a quotient. So it's the first term, x plus 2 squared, divided by the second term, x. It's the quotient of those two terms. And it's the one in the denominator is always the one that you are subtracting. Okay? Well, that is a single logarithm, and it is fully simplified. So I'm going to box that as my final answer. Okay? And then the last one, again, I have a coefficient of 1/3, but notice that that 1/3 is the coefficient of not just this original term, since there is a square set of brackets here. That would have to either get distributed to both, or I can wait with it and deal with it next. So I'm going to wait on it in this case. And I'm going to deal with the stuff that's in the square brackets, because just like with parentheses, I'm basically saying I'm going to do this stuff first. And since I'm adding that stuff first, I'm first going to deal with the product property and rewrite this as the product of the two terms that this logarithm is of. So those two terms being x and x plus 1. And notice this is also a log base 2, so it would be the log base 2 of the first term multiplied by the second term. Okay, so I have log base 2 of x times x plus 1, the first term times the second term. And notice that I left that 1/3 alone. It is still out in front. Now, because I have so many parentheses going on here, I'm just going to point out where these parentheses all came from. First, I have my first set of parentheses around the x plus 1, so that hasn't changed. That's still here. Next, I had this other x, and that x and this x plus 1 is being multiplied together, so I'm going to be having to take the log of this times this. So I put square brackets around it to show that this logarithm is of that whole product, the first term times the second term. Now, because I have square brackets here, and I didn't want to confuse square brackets with square brackets, these square brackets on the outside I rewrote as regular parentheses, because square brackets and parentheses basically mean the same thing, to show that this 1/3 is times this whole expression. Technically, I don't need those parentheses because there's only one term in them. So I'm just going to erase that so I can see what I'm going to do next. I have this 1/3, and it's times this whole logarithmic expression. So I'm going to, again, since it's a coefficient, use that power property and bring it in as an exponent, and it's everything that this logarithm is of will be to that exponent. So it's the whole square brackets here. So everything in that square brackets is to the 1/3 power. But remember that a 1/3 exponent, or this rational exponent, is just representing the root. And the index of the root is the denominator of this rational exponent. So this will be a cube root. So this is just log base 2 of the cube root of x times x plus 1. Now that that is fully simplified, I'm going to box it as my final answer. So whenever you're doing this condensing of log properties, a couple things to keep in mind is that I always try to deal with the coefficients first to get them out of the way. The only time I did not deal with the coefficients first was down here, because I had those outer square brackets, and I was dealing with, just like any other order of operations, dealing with the stuff inside of those square brackets first before I dealt with the coefficients. So I dealt with that inside stuff first. So in general, I would use the, get rid of the coefficients by using the power property first, unless you have parentheses, in which case you could either distribute that or just deal with the stuff inside of it first. Next, whenever you have a subtraction, remember you'll be using the quotient property, and whenever you have an addition, you'll be using the product property. Remember that if you have rational exponents, such as the 1/2 or the 1/3, that you should rewrite them as the appropriate root.
It's long, long, it's big, it's heavy, it's wood. It's long.